Welcome protein coders, let's build some coding muscles. Today we're gonna do one or two questions on the concepts we studied before. Okay, so our first question is sum query 2. It's available on GFG. So what question says is you are given an array with few elements, okay, and you are also given a query vector in which every two pair represents a query of sum of range sum. So for first query 1 to 4 it's 10, for 2 to 3 it's 5. So you can use prefix sum also here, but today we're gonna solve this using segment tree, okay, so that we can revise it better. So first step, we will build our segment tree using the array and then we will query into it. Okay, we studied about the build and the query function. Okay, today let's see how we do it into the code. So here is the question. I would urge you to try it first by yourself, then come to the solution. Okay, so first we will take a vector of size 4 into n to make our segment tree. Okay, second step will be building our segment tree. So we will call a helper function build, which will take segment tree index L and R and segment tree and array. Next we will take a vector answer for our answer, and at the end we will perform our queries I from 0 to 2 into q, and every step I will increase I by 2. Starting index will be query I, end index will be query I plus 1, end index. Okay, now I will store the result of every query in the res integer. Okay, and I will query for start and end, and it will take again segment tree index L, R and segment tree, and at the end I will store the result into the answer, and at the end return the answer. So let's first build our segment tree. Okay, so our function will take segment tree index L and R and segment tree vector and array. First thing is, if L equals to R, that means we have reached the end of the or leaf of the segment tree. Then we will simply store ARR of L in segment tree of I and return, or else we will find the mid and build the left and right subtree. So we will make a recursive call for the building left subtree and recursive call for building the right subtree. And at the end, while returning back, we will sum the children nodes of the current segment tree node. Now let's code our query function. It will take start end and segment tree index L and R and our segment tree. Right? Return type will be integer. So we have three cases, if you remember, in our query segment tree: for no overlap, total overlap, and partial overlap. For no overlap, if our L and R range of the segment tree node is out of the start and end query range, so we will return 0. Total overlap, if our L and R range of the node is completely inside or equals to the start and query range, then we will simply return the value of the segment tree node. Or else, if there is a partial overlap, we will query both the sides of the segment tree. Remember? So we will find the mid and query both the sides, and we will return the sum of them. Right? So one more thing, when we are querying, if you remember, we have given 1 based indexing. Okay, so we will subtract 1 from start and end. Okay, so let's quickly submit this and see if we can pass all the test cases, and let's quickly see. So yeah, we have passed all the test cases, and if you have any questions, please mention them into the comment box. Let's jump to the next question. So our next question is range minimum query, and it is similar to the range sum query. Here also we have given an array and a query a comma b, a range of query. Okay, suppose it is 1 to 3, then we have to find the minimum in the range of 1 to 3, which is 2 here, and it is very similar to the range sum query. And here we can't use something like prefix sum. Okay, we have to use segment tree here. So what we will do is we will do a slight modification. Just instead of using the sum, whenever we are doing the sum, we will just take the minimum of the elements. Okay, let's see this in the code. You will understand much better. So here is the question. Again, I will urge you to first try it out yourself, then come here. Okay, let's start. First, for constructing our segment tree, we will again define a vector of size sgt of size 4 times n, right? Then we will take help of our build function, in which we will pass segment tree index, lr, segment tree and array, and at the end we will return the segment tree. So let's write our build function. It's very similar to our build function in array in sum query. Okay, so again we will have our segment tree index, lr, segment tree and array. If l equals to r, we will assign the array of l into our segment tree node and return, or else we will find mid and construct recursively the left and right segment tree. So we'll call the build function for left node and the right node. Okay, and while returning back, we will take the minimum of, in range sum query we are taking the sum of, here we will take the minimum of the children nodes of the segment tree. Okay, so that's all. Now for querying, I will just return the value I will get from the query function for range a comma b. Okay, so let's write our query function. The return type will be integer. We will have start and segment tree index, lr, and our segment tree array. So again we will have 3 conditions. If you remember, no overlap, complete overlap and partial overlap. For no overlap condition, we will return a very large number. Okay, because here we are taking the minimum of the elements, okay, values. So we will return a very large number. I don't want this value to come into my answer, so I'll return int max. If there is a complete overlap, we will simply return the value of the node, segment tree node, or else I will return the minimum of the value which I get from the left query and the right query. Left query means the query in the left subtree of the segment tree, and right query means the query in the right segment tree of the right subtree of the segment tree. Okay, and that's all. This is how simple it is. Very similar to the range sum query which we have done earlier. So let's quickly submit this and see if we can pass all the test cases. And yes, indeed, we have passed all the test cases. So that's all my side, guys. If you have any queries, please mention them into the comment box. I hope this helps. See you in some other video. Till then, keep smiling, keep practicing. Thank you.